What is going on, guys? Welcome back. In this video today, we're going to take a look at 5 awesome and useful Python decorators that you can implement for your projects. So let us get right into it. Alright, so we're going to take a look at 5 useful Python decorators in this video today, which we can use in our project. And these are going to be decorators that we implement from scratch manually in this video today. We're not going to use decorators from core Python or from some other package. We're going to manually implement them and customize them for our specific use cases. Now, for those of you who don't know what decorators are, they're basically these little annotations that you can add on top of a function to change or extend that function's behavior. For example, the cache decorator from core Python can add caching to a function. Now, let me maybe show you a quick example just so you know what we're talking about here if you've never encountered these decorators before. Basic idea is I have some function. This function has some obviously functionality. So let's say I have process input here with a parameter n, and this function does some calculations, and in the end we're going to get a result, for example, n squared, which is now a very simple calculation. But let's imagine we have something more complicated. Let's use time sleep 2 here to wait 2 seconds. And let's just simulate by doing this that this takes some time to compute. Now, if I print process input called on 5, for example, and I do this a couple of times, when I run this, what you'll see is I'm going to wait 2 seconds, I'm going to get the result 25, I'm going to wait again 25, wait again 25, because even if this was a real function, it would have to do all the calculation all the time. The idea now is there is a decorator called cache, or also LRU cache, in functools. So I can say from functools import, for example, cache. And by adding cache as a decorator to this function, this is how you add a decorator at cache. This is going to now be a cached function, which means that when I run this again, the first time I'm going to have to wait. The next time it's going to recognize I already know that input value. I can return 25 immediately because that's a cached result. So this video is of course not about caching, but this is just an example of a simple decorator. It's a little thing, a little annotation that I add on top of a function to extend or to change the behavior of that function. Now, of course, in the case of caching, this only works or should only be used for deterministic functions. But again, this video is not about caching. What we want to do in this video today is we want to implement ourselves 5 different decorators that can be very useful in any project, I would say. They're quite universal in general. And these are decorators that can really help you to avoid duplicating code to do basic stuff. For example, let's start with the first decorator right away. Let's say I want to have a decorator that allows me to measure the execution time of a function call. So I want to know how long does it take when I call this function to actually get the result of that function call. And for this, actually, let's go back and use the same function that we had before, this process input function, which of course is going to roughly take 2 seconds now. What I can do if I don't use a decorator is I can say import time, and then basically I can say start is equal to time.perf counter or time.time, whatever you want to use, and end is equal to that as well. And then in between here I can say process input 2, and I can say in the end, after calling all of this, I can say time taken, and then end minus start. And of course, if I run this, this is going to work. It's going to execute the function call, and it's going to measure the time. And it's going to give me that result. Now, if I have to do that over and over again, and I want to do that all the time, everywhere, this becomes quite tedious to do it every single time like this. So what I can do instead is I can take this logic and turn it into a decorator, which I can call time logger, for example. Or I can also log into a file. It depends on what you want to do. But the basic idea now is that I go ahead and define a function called time logger, for example. This is going to be the name of the decorator. And this function here takes a function as input. So the time logger will take the function, whatever it is. It doesn't have to be focused on process input. It can work with any function. It takes that function as a parameter. Now, in this function, I have an additional function called the wrapper function. And this function needs to be very flexible in terms of the signatures. So we're going to allow any arguments, and we're going to allow any keyword arguments. And this wrapper function will do the following. It will take the function, it will call it, it will take the result and return it, but it will also measure the time that it takes to do all of that. So it's going to say start is equal to time.perf counter. end is equal to the same thing. And then I'm going to say result is equal to calling the function on the arguments and keyword arguments passed. And then we're going to return the result here in the wrapper. And of course, before that, we're going to print the time it took to do that, time taken, and minus start. And then we're going to say return wrapper. The idea is we take the function and we call the function in another function, and we actually return this function now instead of this function. So we basically wrap this functionality around the function that we're passing, which means that process input is going to be turned into this wrapper function that calls process input, but it also does all the stuff around this. So if I again just do the same thing, if I just call print process input 5, this is not going to do anything, so the function is still the same. It will just execute and give me the result. But if I now add to the function up here the decorator time logger like this, this is now going to enhance this function with a timing behavior. So if I run this again now, it will still give me 25, nothing will have changed, but I also get this logging message here, time taken 2.0097 and so on. Maybe we can format that a little bit better. So maybe I can use an F string here, time taken, and then some curly brackets here, and then let's say 0.4f. And when I run this now, we should have a better formatting. But that's the basic idea of this simple decorator here. I think this is quite useful because oftentimes you want to know how long it takes to execute something if you try to see how efficient it is when you change the input size. This is a very simple way to do that. You just have to define this once and then you can add and remove it from functions. This is also a little bit related to debugging maybe. Maybe you don't want to have this necessarily in production, or maybe in production you want to actually use the logging module, but this is quite simple because I can add and remove this easily. I can comment it out and then I just have my basic behavior as before. But with this annotation, with this decorator, I get the information about how long it took to run this. So that's a very simple and useful decorator. The second one I want to talk about is the retry decorator. So sometimes you have functions that are error prone or prone to error. So let's say I have here an error prone function. And to make it somewhat realistic, let's say I have a random chance of this function failing. So let's say if random is less than 0.9, then we're going to raise some value error. I'm going to say error. And otherwise, we're going to just print success. So what could this actually be? This could be some API call. This could be some operation that oftentimes fails, oftentimes does not fail, but if this function can produce errors, we want to maybe retry because at some point it might actually work. So in this case, 90% of the time this function will fail. We can try to simulate this. I can just call this function and see what happens. If I just run the script, I'm going to get an error. I'm going to get success now. I'm going to get an error. There you go. Rarely I will get success, but sometimes I will get success. So you can see most of the time I get the exception. There I had a success again. That's the idea of the function. Now, what I can do with such a function is I can call it, and if I fail, I can try it again and try again until I succeed or until I reach a maximum level of retries. So for example, I could say something like, try to call the function error-prone function. If this fails because of a value error, then just try again. So maybe we can do some while loop around this, while true. If I get an exception here, I can say pass, or I can say time sleep 1 second and try again, which can make sense for API calls, for example. But I can implement a logic like this. What I can also do is I can turn this into a decorator, and I can also parameterize this decorator. So I can say up here, define a decorator retry, and retry is going to have the parameters retries, so the max retries. Let's set this to 3 by default. And let's say that the exception that we're waiting for is going to be exception by default, so any exception. And now in this method, in this function here, I want to have another function that I'm going to call decorator. this function is going to take the function as before, as an input, and this function will have another function in it, the wrapper. So, like this. And this will take, again, args and quarks. And the idea now would be to try as many times as we define it here in this parameter, and then if it still fails, we can re-raise the exception, or we can raise the exception in general, and otherwise we're just going to try to succeed. So we can say attempts is equal to 0 by default, and then while the number of attempts is less than the number of retries, or max retries, we're going to say try to return the value of calling the function on the arguments and keyword arguments. And if I get the exception type, so accept exception as E, then we're going to just say attempts plus equals 1, and we're going to print maybe, I don't know, let's say failed, and then we can say maybe in parentheses here, attempts out of retries. Yeah, and in the end, if we get out of this while loop, we want to raise the exception, and here we want to now return the wrapper, we want to return the decorator, and that should be it, because here we return, here we raise, here we return, and that should work now. So if I go ahead and I call the error-prone function again a single time, I will get an error. If I do this now with the annotation up here, if I say with the decorator retry and I say retries is equal to 5 and the exception is equal to value error, I can run this and you can see I get fail, 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 success. This was now coincidence that it worked. I can, of course, also fail 5 times, or I can succeed immediately, or I can succeed after the fourth time, or in this case now, I don't succeed at all. So this can be quite useful if you have error-prone functions. Just add retry on top of them, and they're going to be executed multiple times. So, or until they succeed, or until you exceed the retries. And of course, you can also add some stuff like delay up here. So you can say delay is equal to 2. And then you can say if it fails, what you want to do is you want to say time sleep delay. This would also work, right? So you could have some mechanism for slowing down. And in this case, now let's go and say delay equals 2. And you can see now it's slowed down a little bit. In this case, it doesn't really make a difference because it's just randomness, but if you have some API calls, this can make a lot of sense. So this is a very useful decorator in my opinion, because we don't have to constantly re-implement this logic, this process of trying something again a certain number of times. We can just define what it looks like once, we can parameterize it to keep it flexible, and then we can just reuse it on any function that is prone to errors. So this reduces the amount of duplicate code massively. Now, let us move on to the next decorator, which is the type checking, or I would rather call it type enforcing decorator. So in Python, of course, we have type hinting. So I can define a function add, I can say a is an integer, I can say b is an integer, and this is type hinting. I can then return a plus b, but of course, since this is Python, nothing prevents me from calling the function on the string 10 and on the string hello, which is going to lead to a string concatenation. This is valid Python code, no problems, because this, of course, is just a hint, a type hint. Now, of course, I can use tools like MyPy to enforce them, but I can also enforce them actually in Python code, so that it's impossible to actually run this with incorrect types, and for this, we can write our own decorator. So let's call this decorator type check, and the idea of this decorator is that we're going to pass a list or a collection of types, and these should match the types of the arguments. So I'm going to say expected types with an asterisk to say that this is of variable length. Then I want to have a decorator inside of here that takes the function as a parameter, and then I want to have a wrapper again with arguments and keyword arguments. And then I want to say that the goal is to iterate over all the arguments and see if they have the correct type. So I want to say for argument and expected type in zip the arguments list. So zip basically args and expected types together. And if not is instance, if the argument is not of instance expected type, we're going to raise a type error. And we're going to say that we expected, and then we're going to say expected type, but got type of the argument. And otherwise, we're going to just do nothing. In the end, if we get out of this loop without raising an error, we're just going to return the value of the function call. So calling the function on args and quarks, of course, with the asterisks. And then we return wrapper and decorator. So again, running this without decorator results in a valid function call. If I now run this with type check as a decorator up here, you're going to see that we get, actually we have a problem. What did I do wrong? Let me read the error message again. Takes one positional argument, but two were given. Oh, sorry. I need to, of course, specify the types in here. I need to say that I'm expecting actually, so the type hinting is irrelevant. I can call this AB, but I need to specify that I want to use the type check decorator actually with the expected type. So when I have int and int, and when I run this now, you're going to see that I get a type error expected class int, but got class string. This also is the case if the first one is actually an integer. So if I change this to be the correct type, this is still going to fail because the second one is not the correct type. But if I change this as well to 20, then I'm going to get the function call. So this is a way to enforce the types with a decorator. So if you're building a framework, if you're building some package, or if you're just building an application that wants to enforce types for some reason, you can do it like this. Just build this decorator, raise a type error if they're not consistent, and then you have type enforcement in Python. So the fourth decorator that I want to talk about is quite basic. It's the debug decorator. For this, we're going to use the same function here, add. And the debug decorator is quite flexible. You can add whatever you want to it. Basic idea, again, is you define debug, taking in a function, and the wrapper in here takes in, again, arguments and keyword arguments. And now you can do anything you want around the process of calling a function. So you can say, for example, some log message like calling function, and then we want to say function underscore underscore name underscore underscore with arguments args and keyword arguments quarks, and then I want to actually call the function. So result is equal to calling the function on arguments and keyword arguments, and then I want to say result was result. And of course, you can do stuff like timestamps and date and whatever you want to have as a debug information. You can log anything here, you can print anything here, you can do whatever you want, but this is just a thing that you can use in your applications with the goal of turning this on and off. So right now I have my add function, works, okay. If this is some complicated function, I can add a debug tag on top of it. And of course, this is a problem. For what reason exactly? Yes, of course, because I missed the asterisks. So like this, it should work. There you go. And now I get the function call with some printing here, calling function add with arguments 10, 20, and keyword arguments nothing. Result was 30, and then I get the result. So it doesn't have to be this specific decorator that you end up using, but just the idea of having some decorator debug that you can comment out, or you can add and remove to functions to run them in debug mode to get some more information about them. This is very useful. Now, of course, you can also replace this with IC, so with ice cream. I have a video on that on my channel if you want to check it out, but this is a very useful decorator as well. And finally, I want to get to something, I would call it more exotic, not necessarily exotic, but maybe not always needed, but it's a rate limiter. So let's say you have some function that you don't want to call too often in a certain period of time. You can limit the rate of this function. You can limit how often it can be called in a certain period of time by using a decorator called, or whatever you call it, but by using a decorator that represents a rate limiter. So let's say I have some function here, fetch data, and this function, what it does is it downloads some data. So fetching data from an API or something, or using some system resources, some GPU resources, something that you want to limit. And let's say we simulated this takes a second to actually be done. So maybe received data. Now, what I can do here, of course, is I can just call this function many times, and I'm going to be able to do that. Fetching data, receive data, fetching data, receive data. And if I want to limit this, what I could do is I could keep track of the function calls and the time and everything. But let's say I want to do this every time I call this function. So what I can do for that is I can define a decorator rate limiter, which is going to take calls and periods as parameters. It's going to have a decorator, again, that takes function as a parameter, and of course a wrapper that takes arguments and keyword arguments. And then we're going to say that we want to keep track of a call list, of a list of calls. So let's say that we're going to define that list up here. Last calls is going to be equal to an empty list. We're going to make this list non-local so that we can actually access it in the wrapper. So non-local last calls. And we're going to say right now we have the following timestamp, time. And we're going to say that we want to get all the function calls that are in a certain time period. And this time period is going to be the following: call time for call time in last calls, if the difference between the timestamp right now and the timestamp back then is smaller than period. So this is all in seconds. So if I say period is 5, that means I have 5 seconds. And I can say, okay, if basically this list comprehension is going to give me all the function calls that happened in the last 5 seconds. And what I want to check is if the length of that list is above the number of calls, so greater than the number of calls, I'm going to raise a runtime error saying limit exceeded, or let's say rate limit exceeded, try again later. And if I succeed in running the function, I'm going to, of course, append this function call, the current timestamp, to the list. So I'm going to say last calls append now. And then I'm going to return the function call. I'm going to actually execute the function call and return the return value. And here I'm going to return the wrapper. And here I'm going to return the decorator. So if I run this now with the decorator active by saying, what was it, rate limiter. Let's say I want to allow for 2 calls in 5 seconds. So let's say calls equals 2, period equals 5. And then I want to activate this rate limiter. If I run my script now, you're going to see fetching data, receive data, fetching data, receive data, and then boom, failed. Because I'm trying too often. I'm trying to do this within 5 seconds too many times, so I have to raise the exception. If I say that I want to have 2 calls per second, it's not going to be a problem because I am doing this too slow. So I can keep going, keep going, keep going. Nothing is going to limit me because I am allowed to do 2 calls per second. Now, if I change the sleeping time to 0.1, this is going to become a problem because I'm going to exceed the rate limit. That's the basic idea of this. This makes sense if you have some function that uses some resources or uses some resources that you want to limit. This can be quite useful, even though, as I said, this might be a little bit more exotic and less universal. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.